Thank you. So, hello everyone. Thank you for anything better to do at this time of the day than attending this talk. My name is Daniel Barbu, and here with my colleague, we are going to talk a little about the threat intel and how we implemented the threat intel system on our own to gather some relevant info for the environment, as the introducer said. So I'm Daniel. I'm working for Adobe as an INFOSEC engineer, and he's Bryson. He is from US. And please give him a round of applause, because since yesterday morning, I don't know for any reason, he's kind of sad, right? So
this is not my fault. I did not vote for either of them, I promise.
Yeah, he just wants to make threat intel great again. Anyhow,
No.
So to start with, one of our disclaimers says something like the views and opinions expressed in this presentation are those of the authors, which are like us, and do not necessarily represent the opinions of or positions of our employer and or affiliated organizations. Sorry for that, but we needed to tell it. Also, the presented data was gathered using a public cloud and not Adobe-owned infrastructure. What we are going to talk about today, it's like simple stuff. And by simple stuff, we mean finding the X in this, which is here, in this image. So the data that we are going to show, it's relevant data for your environment again. The tools we use are open source tools, which means free, and highly customizable tools that you can actually go and implement in your environment, like right after this talk. About threat intel. We realize that threat intel is a buzzword, and this is why we used it in our title. So also, I know that, or I believe at least, that maybe 90% of the people in this room, when actually going to a conference or a vendor area, Black Hat, let's say, just see a lot of vendors, a lot of marketing people coming and throwing things at them and feeling like every other third party is trying to sell them some threat intel. So why not build it yourself, right? So we try to divide this presentation into like three main areas. What we are trying to accomplish, how we are trying to accomplish it, and of course why. So what we are trying to accomplish? We are trying to improve the understanding of the adversaries by understanding their techniques, tactics, and procedures. We are trying to see actually who they are and at least attempt to understand why they are attacking us, right? Additionally, we would like to leverage the existing infrastructure. We are not necessarily interested in, buying additional hardware, because we all know that doesn't work for management. We want to leverage the existing infrastructure. We want to add only open source and almost free tools. So we want to get value from that system and from that implementation instantly. Additionally, we want organization-tailored IOCs. We are not interested in those third-party IOCs that say something like, yeah, this IP is targeting you, but it's targeting you and another 100 organizations in the world or in your industry. So by implementing a threat intel gathering system, you will be actually able to understand who's attacking you and your environment. And of course, everything goes back to automation. Automation is critical also in threat intel, and we wanted to change this picture, right? So this is not necessarily relevant. And the picture we first introduced was the one with the Mimi saying that automate all the things. Yeah, that didn't went through legal. We needed to use stock photos, so this is the kind of photos that you will be seeing during this presentation. Let's see what's next. Next, it's why. Why did we want to do this? Because we see too many sources of IOCs, too many sources of third parties trying to sell that to us, and too many false positives. So for example, our Security Operations Center analysts see a huge number of alerts with less relevance. So out of like 10,000 of alerts, maybe 2 or 10 or 20 are relevant for that specific day. And we are going back to the tailored IOCs, and we want to see relevant data. We want our analysts to actually look into the data and to actually take action upon what they saw there. Also, I will skip this non-relevant thing because I feel I already talked about it a lot. Everything goes back to the time and cost. So in order to implement what actually Bryson is going to show you, it will take you maybe a couple of hours and with extremely low cost. And by that I mean some hardware. And also we implemented these systems on a Raspberry Pi system, and it kind of worked until the traffic was extremely high. So the cost is low, the time is it's okay, so I think that you should at least give this a try. Usually these kind of systems fail to identify who's attacking you. Fail to identify, okay, we know that again APT is a buzzword, but fails to identify the APT threat actor. How we wanted to do this was in a PDCA manner. I don't know how many of you are familiar with PlanDoCheckAct thing, but when developing this system, we said, okay, we should model that. So we started with the plan. And I think by planning, the first step in planning should be investing in your people. And by that I mean send them to training. But send them to relevant training for what you are going to use, or make them and give them time to understand the difference between a lot of tools. So you have like tens of IDSs, tens of vulnerability management systems. Give them time to make comparisons and see what's better for your environment. And to see what's better, you need to also understand your environment. And by that I mean, don't just try to monitor something that you don't know anything about, because you cannot defend that. You need to see exactly what are your developers trying to do there, what are your SREs trying to achieve in their day-to-day work. Do not just go to them and say you need to implement that without asking them, without seeing their opinion and without seeing things from their point of view. After that, after you understand your environment, after your people made a comparison between different resources, do step back and do start to set up some monitoring tools. And by setting up monitoring tools, I actually refer to not just deploying them, but start to actually fine-tune them. So deploy a rule, for example, trigger on an alert, see what that alert does for maybe 24 hours, 48, it depends on the environment, and constantly fine-tune that. Once deployed, an alert should not be left like that. It should be constantly reviewed. Also, by checking, we mean take some action on the data. So if you have like an engineering team that deploys a tool and you fine-tune it, right? But no one looks at the data they are using there. They are showing there, sorry. That's useless. That's a security operation program that is not working at all. So we used to say that the security engineering team is the one building the shovel, and the analysts are the ones using it to dig the hole. And by hole, we actually mean threat hunting also. So for this one, we said, okay, we need to set up Suricata IDS, we need to set up Bro IDS, for different reasons. So this is why we installed two, and we'll talk about it more later. And to monitor it, we need to forward all that data to Splunk and actually look at the data. And to look at the data, we use some dashboards that we are going to show you also. Take action on the information you gather. So by taking action, I mean, don't just look at the dashboards, because otherwise you'll be just a manager looking at some nice graphs. Gather the IOCs from there and start hunting for them. Start deploying some alerts for those IOCs. And we are coming again and again and again to automation. Unfortunately, this PDCA cycle, it's a cycle and never ends. So after you gather some IOCs and you start to alert on them, go back. So again, train your people, understand the environment, and adapt. We started with Suricata. Suricata, apart from being a nice animal, it is also an IDS, or at least it's the name for an IDS. The reason for using Suricata, one would be it's open source. The second one would be it has custom rules. You are able to adapt some existing rules, you are able to import some rules, and you are able to also create some rules. It is Snort-based, because I think that many of you are familiar with Snort. It is multi-threaded and it has automatic protocol detection and so on. How do you set this up? You just, I don't know, follow the steps on the internet. It's extremely easy. So it took us like, again, about an hour to set everything up and about 1 month to gather the information. Next, we set up Bro IDS. And in the past couple of days, me and my friend Bryson tried to talk about Bro and stuff like that. And he's also trying to learn some Romanian. So, do you know how to say Bro in Romanian?
Ce faci, frate? Right,
So,
right? Something
no.
like that? Is that pretty close?
No.
Frate. Frate IDS is essentially what this is, right?
Frate IDS, are you
Frate
for real?
IDS.
Okay, okay. Again, so Bro, it's also open source, and it's a network analysis framework. Bro, it's also detailed in analyzing the protocols, and Bro, it's highly customizable like all the others. And the reason why you use it in conjunction with Suricata is because it provides this kind of history and connection state, which allows us, and as Bryson is going to show further, that it allows us to see if we have data exfiltration for the IOCs that we are analyzing. In order to set it up, grab a beer, and again, look through the documentation, because it's that easy to set everything up. Using the stock photos, of course, we weren't able to put the Splunk logo here, right? So the closest thing this guy found to Splunk was Spelunk, which is like caving stuff.
It's like cave diving or something like that.
Which is actually makes sense, because we are going into Splunk every day, and we see huge amount of data, and by that I really mean huge. And it's like going into a cave, like first explored cave, so it's hard. So this is one of the reasons we are trying to gather all this information, and also this is one of the reasons we are trying to show you how we did it. Splunk, it's a log aggregation tool. I'm basically sure that you are more familiar with Splunk than Suricata and Bro. So how many of you actually use Splunk like in your day-to-day? Okay, not you guys. Anyway, so I saw some hands, so I'm glad to actually see that. It's an events-based tool, it's search-driven, and by search-driven we mean like some of our searches are like 3 words long, some of our searches are like 200 words long, so that actually means search-driven. When you set it up, it's extremely easy. So you just go to Splunk documentation, you just, I don't know, register there, so you have like an enterprise paid, of course, subscription, and you also have the educational purpose one, so it's actually very, very easy to set up. I'll let my friend Bryson here to talk more about this and how we forwarded everything to Splunk. We'll go through the demo because we usually know that works, and it worked like 30 minutes ago. I don't know, we had a backup demo which doesn't work, so unless this one works, I don't know what we'll do. So yeah, go ahead, Bryson. Thank you.
Yeah. So, yeah, for you guys, can I see the hands again? How many have used Splunk? Okay. Yeah, you guys got to try out Splunk. Splunk is awesome. And like Daniel said, you can go online, and there's a free version you can just install on like any VM and play with it, and just, it's amazing. It's really cool. I am a huge Splunk fanboy, so, you know, lots of fun. So one of the things that you need to do is you need to set up a listener on Splunk. So you go in to your settings tab, jump into the forwarding and receiving part, and then you're going to configure a receiving port. And this is just where all of your data, all your log files will be coming in. So then from there, you need to jump onto your hosts that you want to forward the data from, like Suricata and Bro in this case. and you set up the Splunk Universal Forwarder on those hosts. And it's just a simple agent you install, set up, and you point it to your Splunk server with that port that we already set up, and then you identify the logs that you want to monitor. So in this case, we had Bro and Suricata on the same box, and we just pointed the var log Bro over to Splunk, and the same with the Suricata logs. And the Splunk Forwarder does all the work, shoots it on over, and you have to go in. Oh, you do have to go into the Splunk Forwarder etc file, the config file, and make some modifications to send it to the correct index and source type, which, if you're familiar with Splunk, is just a location within the data that it separates it out and puts that data. So it's fairly easy to set up. And the nice thing about Suricata is it comes already as JSON data, which Splunk parses out perfectly. Now, Bro is a little trickier. You have to install the Bro app, but again, it's fairly simple. And then once you shoot this over into Splunk, we can just pop in our index that we forwarded that over. In this case, Suricata is the IDS index, and we start getting our events, and it parses it out nicely, gets your dest IP, your dest port, your nice blacked out part here. It's great. So, and then we can take that data and we can manipulate it and turn it into our valuable threat intel that we want. Now, this is a big old long nasty search that we use to spit out the cool threat intel data and separate out all these IDS events into valuable data. So for those of you who aren't familiar with Splunk, and for those of you who are, I'm going to kind of go through this piece by piece and explain how this search works, just so that it's not quite such a nasty monster for when you go to set it up in your organization. So index equals IDS, we're identifying the Suricata data that we want to access. Source IP is not equal to 172.16. In this case, we only had one host, just a cloud host that we set up to listen with Suricata and Bro. It was in a 172.16 subnet, so we don't want to see any of our source IPs in your environment. You'll try and get rid of, you'll want to include 192.168, 10.0, and any of your external IPs so that your IPs don't end up on a threat list for whatever given reason. Next, we're going to use some of Splunk's stats functions to go through and count, as well as count the number of events that are happening, separate it out into distinct values by IP, look at the actual signatures that are coming out, and format it in a nice way so that we can actually get some valuable data on each of those IPs. Next, we want to know, we don't want to just know what they're doing, but when they've done it. And so we can use this function right here, your eval last seen, and then this is just some time parsing. And it takes the current time and pushes it out to your to that event so that you can know when the last attack happened. And then this is just a bunch of renaming so that we don't end up with things like source IP underscore IP, and instead we can call that threat actor, which is much more readable. We just do that with every field. Now this is something that you can choose, you can change up. In our case, we wanted to say, so where sig count is greater than 1, what we're saying here is, if you've ever worked with an IDS, you know that you're going to have false positive signatures, right? I mean, you always do. So what we're doing here is we're counting the number of signatures that we've seen per each IP, and we're saying, okay, only those that have more than one signature, we're going to call threat actors. And that gives you a little bit higher confidence in these threat actors. Now you can go in and modify that. You can say, I only want those that have more than 2, or I want everyone, but that's kind of up to you, and you can kind of adjust that. It's important to note that prior to this, you're also going to want to go through and, depending on your IDS, tune this search to get rid of any particular signatures that maybe don't matter in your organization, or signatures that fire a lot but fire as false positives. Whatever tuning is necessary to tune out those false positives. It's just kind of a process. You run the search, you get 9 million events back or something, and you go, okay, I got to work on this. And then you sift through it, find what's actually valuable, add it to the search until you trim it down to the good stuff. This is a cool function in Splunk. IP location allows you to input any given IP address, and it automatically goes out and gives you the location of that IP. So it spits out the country, city, location, everything, which is awesome. And then we're just going to say table last time, which gives us a nice big table of all the fields that we want. You can pick whatever fields you would like in your threat list. And then what this does, this input lookup field, input lookup append, what this does is it goes out to our current threat list, looks at it and says, okay, which ones are on that list that we didn't see today in the search that we're running, but that we don't want to delete and get rid of, so let's add them back to this search. So it just takes the old ones and adds it to the current search as well. And then we get rid of any duplicates that might have happened because of that and output it to your lookup table, which is essentially just a CSV that sits in Splunk that you can access at any given time. And that's it. That's essentially the backbone of this whole idea of taking your data and leveraging the infrastructure that you already have in place to identify the threat actors that are hitting your organization. So from here, you can then take that search, and you don't have to run it manually. You can go in and set it up as what's called a scheduled search. So you set it up, and let's see. You just go to settings, searches, reports, and alerts, and then jump in here, input your search, input the time frame that you want to run it on, and then you can schedule it to run. For me, I tended to run this one every day looking over the past 3 days. That could be over the past 7 days. It could be over the past 30. It just depends on how resource intensive you want this search to be. Okay, now we're going to hope that the demo gods are happy with us today and that this works out. But like I said, we've got an instance set up of Splunk that we have checked out. Oh, thank you. So this is our Splunk instance that we have all of our Surcata and Bro data flowing to. So, for example, I can go in here. Can you even see that? Not really, huh? Can I do the zoom? Ooh, there we go. Okay. Yeah? A little better? Okay. So we can jump in here and we can look at all the events that are coming in right now. So you can see, you can go in and check the alerts and see that we have some malformed DNS requests. Now these are coming from our host, but you know, like I said, some tuning is necessary when you use these. So to look at our current threat list, we just say input lookup and the name of the lookup, and that should spit out what we have available currently on our threat. So you can see here that we have 119 actors in this threat list that we have seen attacking just this one IP address. We have the time, we have the signatures, the actor, and the location. Now, you can do some pretty cool stuff with this data. I mean, it's useful to have, but it's not useful until you actually do something with it. So what we've done, and like Daniel was saying, the catchy manager reports, you want to build a dashboard, and that's one of the things that Splunk is really good at, is building some really cool dashboards. So this one is, here we go. So right here, this just uses that same search to feed in, and this is just over the last 7 days. We've seen 40 different threat actors attacking this box. We've seen 1,400 different attack events. Utilizes that map data, or that location data, to build a nice map so we can see that, you know, most of our attacks are coming from, you can see Denmark, Finland, Germany, mostly from China, several from the United States. This is just over the last 7 days. We can come over and change that and say, well, we want to know what's happened all time, which, what is this, past month or so that we've had this set up? And so we've had 119 different individual attackers. You can see their different locations and their signatures. Now this one's really interesting because now you can know what the threat actors are doing. In our case, we just had, like Daniel said, a cloud host set up, had a web server on it, had SSH open to the world, and a few other things to try and kind of attract some attackers. And what you can see, and you can see that easily here, we've got our top signature easily, and I don't know if you can read that, but it's libSSH based frequent SSH connections likely brute force attack. And then the next largest one is potential SSH scan, SSH brute force tool. So nearly 66% probably around of the attacks were all SSH attacks. Now, if I'm looking at this and I'm wondering about my own organization, I'm thinking, we probably have SSH open somewhere that it shouldn't be, and we're getting hammered on SSH. So that's useful to be able to see, and you know, whatever else is going on in your organization, whether it's shell shock or MySQL attacks, some cross-site scripting, anyway. Now this parses out all of that data from that threat list and gives you some information. So we can see that we've got this, here, let's zoom in again so you can see this a little better. We have our threat actor, their location, and the signatures. So this particular IP address, this China address, has only been doing SSH scans against us. They've done 316 since we started seeing them, 316 SSH scans, or at least SSH alerts. It could be that they've done more, and that's just the number of alerts that IDS, or that Suricata has fired. And this particular value, the number of targets, is very valuable because you can know that one attacker, if you have thousands of IPs in your organization, and all the attackers are only attacking one of your IPs, you now know that that's your primary target. That's where you need to put your defenses, that you know what these attackers are trying to do. Or it's possible that that particular host is vulnerable, and that's why it's getting hammered so hard. Aside from that, you can come over here, and we have the potentially related threat actors. So this is a fairly simple search. It's not running any API queries to find out, from who is to find out who's actually related. But what this just simply does is looks at the last subnet and finds if the first 3 octets are similar, meaning that it's in the same /24 address, then it's likely that these actors are related. And so right here you can see that we have 5 different actors within the same /24 from Nanjing, China that are attacking us, and they've attacked us 750 times. Down here you can see that we have this 141.212.122.0 address or /24 out of Ann Arbor that has just been going crazy on us with, I don't know, it's just interesting, with several different IPs, even though it's only 33 events. So they're spreading out their attacks across multiple ones to make it less obvious what they're doing, is my guess. So that kind of data can be very valuable to just dig into and check out. And finally, we have the outbound traffic to threat actors. What this does is leverages that bro or frate IDS that Daniel was talking about, and looks for that flow data to see if we have any outbound connections to any of these threat actors. Now, it's likely that these are just scanning IPs, so it's not likely that these are CNC addresses, command and control, but it is possible. They can always be both. And either way, this is a project, like Daniel said, that really should only take you a few hours to set up now that we've given you all the searches and you don't have to figure out any of this. But I mean, it really should only take a few hours, maybe a day to set up, and you can get all this valuable data in a very limited amount of time. And that's about it for this demo. So, worked, did not crash, which is great. Okay, so let's see. We had the backup, screenshots of the same thing in case all else failed, of course. So just skip through those. Now, it's important to note each of these panels on the dashboard are each panel powered by a Splunk Search. So those of you who have used Splunk in the past understand that that's how these dashboards work. Now, so that you don't have to go through, if you want to create this exact same dashboard, so that you don't have to go through and rewrite those searches, which is a pain, we've included them here so that you can just go through and copy them. Now, I think this is being recorded, and I'm assuming this is being published somewhere. So I'm just going to leave these up long enough so that you can pause the video or something, or take a picture or whatever you'd like, and come back and copy this later. And maybe this will become available. I don't know. I don't know how this works. Anyway, so there's the one for the threat actors by country. There's your search for the top signatures observed. There's your threat actors, the number of targets and signatures detected, that one that brings together and sees how many destinations it's attacking. Potentially related threat actors. This one's a beast. This one goes through and uses some regex to find that subnet. And yeah, that's it. Oh, I actually forgot to include the outbound traffic, but what you do in that one is just run a sub search on the inside. We can include that later. If anybody's interested in more, you can come talk to us afterwards or whatever, and I can make sure to email you that particular search for the outbound traffic through Bro. So yeah.
So this was a demo, and it looks as it worked. I don't know. In my opinion, it worked. This was how it's supposed to be, though. So our conclusion after doing it was that this was easy to set up. And the data we had there, those IPs at least, are valuable because now we are able to go and create some alerts based on those specific IPs or based on those searches, which is like most probably how it should be done since automation. So we consider that valuable data.
And sorry, I just wanted to point out that this was, like I said, this was only what we got with one host on the cloud. If you put this into effect in your environment with potentially tens of thousands of hosts, you're going to get a lot of data because you've got a lot of public-facing hosts, and this is going to be some really valuable data to identify who's attacking you specifically and who knows about you and who wants to get at you. So anyway, sorry, Daniel.
Yeah, and I also believe that the takeaway here is the time and the cost, and also that it actually identifies actors threatening you. So as we promised in the abstract, if any of you read that, the dashboard, it is also a good thing to provide your management because it shows some value for your threat intel program, at least part of it, right? So this is like, these were our conclusions. Maybe you have different ones. We will actually be looking forward if you come to give us your feedback on this, or actually not necessarily the feedback, but please suggest us some further work on this dashboard at least. So thank you for coming. If you have any questions, we can take them now or afterwards, doesn't matter. And thank you again.
So, can you guys tweak your searches in order to determine if the threat actor is doing a manual scan or an automated scan or a periodical scan? I mean, for me, it would be more important, more valuable threat actor that's doing things manually than automatically.
Right. So yeah, no, that would be super interesting to do. What you could do with Suricata, it provides not only the user agent, but a lot of the signatures that come down are specifically for known scanners because it identifies that same behavior, like SIP-vicious scanners and just whatever scanner you have out there. So it could potentially identify who is doing an automatic one, and you could just say have an eval a field that says, you know, automatic equals true or automatic equals false based on whether one of the signatures in that match matches, or signatures in that field matches your any particular automatic scanner. So that would be awesome. That'd be something that wouldn't be too hard to throw in. So yeah.
Yeah,
totally
an additional thing that you can do is actually see the alerts on a span of time. So they have like a constant interval between them. They might be automatic rather than manual, right? Like this, if the time frame it's exactly the same. That can be. I don't know. We'll look into that. Promise.
Yeah, this is fairly rudimentary. I mean, it's pretty basic what we've done so far, but there's a lot more that you could take and do with it like that. And it's just ideas that need to be pumped into it. Yeah.
Next. You.
Okay, next question. Actually, I'll start with a comment. In Snort, I like Snort more than Suricata, you can define the home net variable, so you could determine the direction of the attack. So depending on the signature, you might want to actually enable that feature. I think it should be available in Suricata also, in the default config file. Moving to...
No, thank you. It's a very good thing. Yeah.
Yeah. Moving to the next thing. Let's see where we can start. The approach that you've used is completely reactive. So first, something has to happen, and you actually need a signature in order to use that. With Bro, by default, you don't have too many features enabled. I mean, if you go with something like Security Onion, you get Bro to also log, let's say, the executables that come into your environment. And you may actually use some extra features to also get a copy of other files that get transported back into your infrastructure. But the challenge over here is that you don't really have a way to detect APTs or zero-day attacks. You rely on the signatures that Suricata has, or actually on, let's say, large-scale anomalies like a lot of traffic going out from one particular system, yeah, you might be able to pick that one up. But what about the slick APTs that use, let's say, normal communication channels like Gmail, right?
Okay, so that's a very, very good comment, and thank you for it. This is part of a huge system, not necessarily the entire system, right? And to be honest, we are focusing on the Linux environment, so the exe thing does not necessarily apply. But I know that it can be used for that also, so it needs to be like all kind of environments. With regards to APT again and the threat actors, this is like part of a larger system, right? So we usually use this in parallel with some other honeypot systems, like a huge variety of honeypot systems, and I cannot provide the detailed info on this, but we have additional ways to detect this. So this is actually how we do it right now. And just to mention, we are also looking into using third-party info because we see the value in that, and we use this like a side things.
Yeah, that's an excellent point. This is absolutely not a replacement for your entire threat intel program, or this is not the entire threat intel program. This is simply something, like I said, that could be set up within a day to provide you some useful information that you could then take, and really the backbone is Splunk. So you're saying Snort or whatever other, like you said, Security Onion, whatever other feeds you want to pump in, you could provide those feeds into that same Splunk Search and Dashboard and have those values in there, and then that can be pumped over into whatever threat intel gathering program you have, whether it's crits or whatever your system is. You can then push it into that. So this is in no way a replacement or an entire threat intel program. It's simply a small piece of it. And so you're absolutely right. To gather those APTs and those more reactive actions, you'd require a different system in parallel, like Daniel said. So, but great question.
Okay, thanks.
Hey, okay, so what did I understand from your presentation is that when you're talking about IOCs, you're talking actually about IP addresses. And please correct me if I'm wrong on this. From my experience, actually an IP address is the easiest thing to change from an attacker perspective. So when talking about IOCs, there's so much more in there to look for: hashes, registry key entries, domain names, which are more useful if you ask me. So my question is, do you consider extending your threat intel program there with this kind of information, and if so, how?
Yeah, I absolutely agree that yeah, IP addresses can be swapped out like nothing else. So having domains or something more interesting would be definitely valuable. I mean, we haven't put that into play yet, but that's definitely something that would be useful. As far as Suricata, there may be some way that we could leverage an API to enrich the data. Run a host command and get the DNS, get the resolution before it pumps it over. But I mean, again, that could easily be included with something like this. Now that wouldn't take into account that one that checks if they're within the same /24, same subnet. That of course wouldn't help there. Wouldn't apply in that situation. But I think that would be something that would be very valuable that we could definitely set up.
Yeah, and in order to understand their techniques, this is why I'm telling that this is a part of the system. We also have other honeypots which are only focused on seeing what they do after they are inside, right? Gathering their actions, right?
Okay, thank you.
Thank you also. After we get this information, it is not passive. So basically, we have this in place right now in our test environment, and we alert on those threat actors like when an IP adds to the lookup table, we just alert on that instantly, and we forward it to our threat intel team, which adds it automatically to the threat list, and again alerts if it sees traffic going to that one. So this one only is used to gather the info and forwards the IP to the other system, which actually sees if something from our environment sends data, or it's connecting at least to that part of things. So this is like a honeypot environment, and if we see the same things in the real environment, we double alert, let's say. It's a matter of, let's say, 2-3 minutes between seeing it and starting to alert on it in the real environment.
Do we have any other questions? Okay, now, thank you guys.
Thank you also.
It was an awesome presentation.